Welcome to OpenHive.JS, the podcast for all things JavaScript. We are your hosts, Matteo, Collina, and James Snell.
You literally have 8 organizations that go into third world countries and create a profile for a person and then have to burn that profile every year and start over from scratch because they can't put it somewhere where that government might be able to get at it.
For this episode, we sit down with Mikeal Rogers, IPLD Lead at Protocol Labs, respected leader in the open source and Node.js communities, and long-term friend of ours at Nearform. Unsurprisingly, this turned into a long conversation, so we are splitting it into 2 parts. In part 1, Mikeal talks to us about the importance of good data, decentralized databases, and encryption.
If we just move to a model where I have a tool to build an application and I can decentralize it, all of a sudden everything else gets much easier. Where all of a sudden I can do serverless and I don't need to worry about overloading a centralized database. All of a sudden I can build an application and I can kind of not care about where the data is stored.
Let's get into it. This is OpenHive.JS from Nearform.
Welcome to OpenHive.JS, our podcast on all things JavaScript with Nearform guests. I'm James Snell, and I'm joined today by my colleague Matteo, Collina, and our guest and friend Mikeal Rogers. Hey, Mikeal, how's it going?
Hey, how's it going?
Hey, Mikeal.
Hey, you guys had to do OpenHive. There was already a Hive.js that you had to put the open in front of.
I've been asked, what's the story with the OpenHive.js, and to be honest, I don't really know where that came from. That's what we went with. Right?
I have no clue either, really.
It sounds almost like a foundation name. Like we're always putting open in front of foundation names because we run out of, like, there's always like a proprietary foundation or a prior foundation that did the real name. And then you've got to put open in front of it when you do the open source one.
Just like the JS. It really should be the JS is silent, the open is silent. So let's just call ourselves Hive. Just Hive. So what have you been up to lately, Mikeal? It's been a while since we've chatted.
Yeah. What do we mean by lately? I guess.
All kinds of things.
Yeah. No. Oh wow. Where should I start? I think like the big thing, because I mean we used to talk a lot during the Node Foundation days and a lot of the Node core stuff. And when I left the Node Foundation, I really like pulled myself completely out of that and out of core. I felt really strongly and still feel this way that when you're in a leadership position and you leave, you need to leave all the way. You can't leave a little bit because then people can't fill that vacuum, right? Like they're not actually enabled to take on that work. So yeah, I pulled out completely and didn't really know what to do with myself for a while, to be completely honest. I think, like I was really involved with Node early on and really involved in the community. And there's something of like a career path or a vision that you have where like someday maybe I'll run the Node Foundation, and so that happened, and then that job is not actually fun. It turns out, if you want to know, it's.
I don't know how you did it, man. To be honest, I don't know how you did it.
But so I thought, what am I gonna do now? And tried out some other stuff, tried out some venture capital, and ended up at Protocol Labs. And around the time that I was going to Protocol Labs, because a lot of just my long-term interests were really aligned with them, and I was really impressed with everybody there. But the real thing was I was starting to realize that maybe actually writing code, like actually programming, is the thing that I actually enjoy doing, being that that's what I've done for, at the time, like 17, 18 years. And, when I would get time to sit down and write code, it was always like the most enjoyable part of my day. So it really made me kind of rethink and reframe how I'd thought really about my whole life, because in the technology industry, it's never enough to just be a programmer. Like there's always a pressure to do more. Like you should start a company and you should, be this and be that and go into leadership and all these things that eventually take you away from code. There's really not a lot of examples and a lot of people to kind of look to where you say like, no, just get better at programming your whole life. like that is actually like a very happy path. There's only like a couple people that I can even point to where that was the case, right? Like I think John Carmack is probably the main one that I can really think of, right? Like, everyone else, they move on to something else. Like Gates was a phenomenal programmer, and now hasn't written code in decades, right? So that really kind of reshaped my life. It led me on this track where I kind of found Buddhism as like a way to think about my programming as a practice and think about my mental states when I program, and really kind of guided a lot of the work that I've done over the last couple of years now. And that work has been primarily focused on a problem that I've actually been working on for about 10 years. Since before Node, actually, I've been thinking about and trying to work on this vision of like a peer-to-peer web and a peer-to-peer internet, right. Kind of bringing back that peer-to-peer technology. And so 10 years ago, I was the first employee at the CouchDB company with Damien Katz. And I wrote PouchDB there, or what became PouchDB. And so I've been like working on kind of peer-to-peer databases and peer-to-peer data structures for a long time. And at some point I realized that the way that I was approaching that problem was not going to work. Like the actual kind of replication model of CouchDB wasn't going to work. And this was at a time where a lot of other people were actually picking up that model and thinking that like, this is the way to go. Like Apple actually picked up that model, and that's how a lot of the thinking in Apple's model works. It's very similar to CouchDB, which is similar to Lotus 123.
Go ahead. Very funnily, just if you, for anybody that's listening that don't know the context, you might not know that the full NPM registry replicated with that model for a long time.
Yeah, well, that's because I wrote that registry. Like Isaac and me. So this is a funny story, actually. Like in the early days of Node, there was no package manager, and Ryan was like, "I don't want to write a package manager. Somebody else should figure out that problem." Similar to what he's saying now with Dino. And so everyone did, actually, like everyone who was really into Node at the time had their own package manager. So TJ Hollowaychuk had his own package manager, and all of his packages were in it. I think Tim Caswell had written a package manager. I wrote a package manager that had exactly one feature, which was the dev feature that would set up the symlink for doing development. And I never got past that, so I never added any more features. But me and Isaac were talking, and I was like, yeah, I'd love to move to NPM. I just need this one feature. And he was like, well, I really need a registry. And I was like, well, you add that feature and I'll write you a registry. And so over a weekend, I wrote the original kind of CouchDB registry, which was, it was actually like a couch app, what we called couch apps. So the whole early NPM registry, all of those endpoints that create the actual sort of REST interface for the registry were embedded JavaScript functions that were called like through Erlang processes. Like it was like really, really like future looking stuff, right? Like this is all
like
early days of Node. Yeah. like very like serverless meets like stored procedures, kind of like it was very like future looking stuff. There were some cool things in PouchDB, still are, that were way ahead of its time, and that was kind of one of them. And and so that's why the kind of early registry was on CouchDB. And if you look at the actual data model of the registry, like if you just look at the data registry as a set of data structures, it is still in that model. The way that a package is defined as this single document entity that then has every individual release attached to it. That is kind of from the CouchDB document model.
So on you're talking about the story of the replication model and kind of where you're going there. So you're looking at CouchDB, seeing this replication model, like that's not really working. Where are you at now?
So what I started saying maybe 5 or 6 years ago was that we just don't have the right primitives. I think around that time I was sold on Merkle trees. Funny enough, Merkle trees were really around even in the CouchDB days. I remember having a lot of conversations with Chris Anderson about them. And because Git was, you got to remember, this is like 2010. So Git is like just now popular. Like Git was like a thing, and then there were like 3 other competitors to Git that everybody thought like might win, and they had a lot of big people behind them, right? Like Mozilla was not behind them, like Ubuntu was not behind Git. There were like serious competitors, but GitHub had kind of shifted that, and it was very clear that the center of gravity was moving to Git. And one of the things that made Git really unique was this like different view of the data structures inside of the implementation, and that was all leveraging Merkle trees. And so we talked about it, and they were kind of in the air, but nobody was ever really able to take the Git code base and abstract any reusable primitives outside of Git itself. It's a really tightly integrated monolithic stack. So we really could never figure out a way to use Git, and then nobody was really writing great primitives outside of that. And so for a long time, I was just like, we don't have the right tools. I like have not figured out this thing really. And so I kept kind of banging away at different Merkle tree implementations and poking around. And then actually it's after I started at Protocol Labs, after I'm working here and I'm poking through the stack and I'm poking through IPFS, and I find this thing called IPLD. And I start reading about how CIDs and multihashes work. And I have this realization that like, oh my God, they actually figured out the primitives. they did the thing that I needed. I just didn't know about it. And even more than that, actually, they had a different view of content addressing than I had. And this is this is going to get like slightly kind of philosophical. But I kind of want to talk about it a little bit. So in distributed computing, right? Like you need different parties to agree on something with no trust. And so the way that you do that is with cryptography, right? If we both apply the same math to something, then we know that it is true. So the kind of key to this whole new era of decentralization, whether it's the stuff that I'm doing or literally every blockchain or even Git, what you're using is this thing called content addressing, where instead of saying, oh, like an URL, like, hey, here's where a thing is, here's an address to it and a location where you can get it. You say, no, here's the hash of a thing. And because you have the hash of the thing, you can ask for it anywhere. It doesn't tell you where to get it. But it does mean that if anyone gives it to you, you can verify that you were talking about the same thing. And so if you use hashes as addresses, you have you basically can create links between things that don't rely on any particular location. If that makes sense. But the way that everyone had always thought about content addressing, including me, and I was thinking about this exact problem at the time, and I knew about Merkle trees, and I knew about all this stuff, but I thought about it the same way that everyone else thought about it, which is that this is an address in a namespace, right? So if I hash something and I want to go ask for it, I'm asking for that hash in the context of a namespace. So if you go to github.com right now, you can craft an URL for the SHA hash of any commit in any repo, right? Like you can go, hey, this repo, there's a hash in there. Tell me about that hash. And so that repo is like the namespace of that hash. That's how Git is constructed. But if you do the math on the hashes and you figure out how many potential hashes there are and you realize that these are not actually unique addresses in a namespace. These are globally unique addresses. Even when you create them in the context of a namespace, you should really be able to ask just GitHub, do you have this hash anywhere? And tell me about this data, because it is that unique. In fact, if you sit down and do the math on hash collisions, what you end up with is it will take you longer to generate a natural collision than it will for like many, many decades in the future when that hash is probably broken. So if you see hash collisions, it is an indication that somebody has broken the algorithm, not that you have hit a natural collision. And yeah, so like I had not figured that out. So I and everyone, we were all thinking about content addressing as like, okay, we can create these data structures in a database or in a repo or in a namespace, and then we'll have these addresses that we can float around, and we'll also attach this namespace. But what Juan Benet, who started Protocol Labs, figured out, and he created this entire view of a decentralized internet around the idea that this is a globally unique address, that you should be able to ask for this anywhere in the world. And once you have that view, you start to realize that there are other things that you need in that address beyond just the hash in order to make it globally unique. So you need it to self-describe other aspects of the data so that you can get more value out of it. So like a really good example here is what hashing algorithm is it, right? Like lots of hashing algorithms are going to produce the same number of bytes for the hash. And so if I just hand you a hash, you can't go and get that data because you don't know what hash algorithm that I'm talking about. So the first thing that one did was he said, oh, let's put like a varant in front of it. And then that'll correspond to a table where we can say, okay, here's all the hashing algorithms. And we can keep adding them. So now we have what's called a multi-hash. And now like we can pass around these multi-hashes. And oh my God, like now this is truly globally unique, right? Like I can ask anybody in the world for this data and they can figure out how to get it. And I can get like that data. And then CIDs, content IDs, which is like the basis for all the work that I've done and all the work in IPLD. CID takes us one step farther. So multi-hashes give you decentralized data. Like you can move any chunk of binary around the whole world, multiple worlds, galaxies, and you will always get the same thing back. But to change that data into a data structure, you have to know how to parse it. You have to know a little bit more about the data, right? Like, is this JSON? Is it CBOR? Is it a Git block? Is it an Ethereum block? Like, you need to know how to parse it. Once you assign a parser to it, you now have gone from data to data structures. You now have an agreement using this address between anyone in the world and any programming language in the world, what the in-memory representation is of that data. And because these addresses can be embedded inside of the data, you now have linked data, right? So IPLD stands for interplanetary linked data. That's what I work on. And now that we have links, we can start to create literally every data structure in the world, right? Like this is the foundation for all databases, all file systems. Like you need to be able to interlink pieces of data together in order to create more advanced data structures. And so that's what we've been building out. And from there, at first I was just kind of running the team, very small team, and we've just been improving the tooling in every language for working with the primitives. And finally, that has gotten to the point where over the last year, with kind of poking on my nights and weekends, I've gotten the primitives to the point where I could write a database in them. And so I now have a database called DagDB. You can go and look up. It's pretty awesome, actually. It's, it is still kind of softly released. Like I'm not pushing it really hard on anybody because I still want to work out. There's still probably some bugs to work out, but there is 100% code coverage, so it does do what I think it does. And it is definitely the best software I've ever written myself. I don't know if it's the best software I've ever worked on collectively with other people, but it is definitely the best thing I've written. And it's the best database I've ever written. I've written a few databases now. It's awesome. But yeah, so that's what I've been up to.
Fun stuff. Now, I do want to say, for everyone listening, we're going to throw links into the show notes for everything, the multi-protocol stuff, DagDB, all these, protocol apps. We'll throw links to everything there so folks can follow up on their own. If I say the multi-protocol, the multi-hash, CID stuff is particularly interesting to me. Self-describing data structures, making these as portable and self-describing as possible. The one question I would have there is, outside of the Protocol Labs projects, stuff that you're working on, how extensive has the uptake been on things like CID? Are you starting to see them used in more and more places, or?
Yeah. No, all of these protocols have been adopted elsewhere. I think that the level of adoption corresponds more to how old the project is than how widely applicable it is right now. I think that the space is so new that it takes people a little while to figure out that the problem that they're working on is bigger than their conceptual model of the problem. And until they figure out that, they have a hard time thinking about, okay, what is a larger view of this problem where I would want a bigger generic solution, right? I think that like a good example of this, like outside of the multi-format stuff, is libp2p. libp2p is a project Protocol Labs for basically a peer-to-peer networking stack. And this is like a bigger problem than people really want to admit. Doing something that is truly works everywhere, truly works across languages, works across networks, across different protocols with different fallbacks, that can do like content discovery across different protocols. It is hard. Like Ethereum 2 has now adopted libp2p and is adopting that as their protocol stack going forward. But I don't think that Ethereum 1 would have ever picked up this project, even if it existed at the time, because I think that they needed to go through an entire cycle of having Ethereum to realize, oh, wow, this is like a way bigger amount of code, a way bigger problem than we had really conceptualized. And like, a lot of like good friends of mine love to write peer-to-peer libraries, right? Like, and they're phenomenal developers, so they write really good libraries, like Matthias Boos and Dominic Tarr. Like, they write really cool code and really cool libraries, but they've always constrained the problem that they're working on such that they can have a really small, elegant solution. And so it's always like a nicer piece of code to work with, but then it just doesn't do like 70% of the things that other people want to do with it, right? And and it's the same thing with multi-hash and with CID. Like, if all you're solving is the problem in your little namespace, you don't care about self-describing hashes. You know that you're always using the same hash. You don't care about linking between different formats. You're always using the same format. But if your goal, if your conceptual problem that you're solving is a interlinked internet of data structures, it would be crazy to think that everyone is going to use the same hashing algorithm and the same block protocol. Like, not everything is going to be JSON in the world.
Right. Yeah.
I have a couple of questions for you, Mikeal, on your view of interlinked peer-to-peer databases of the world.
Yep.
There's a lot of focus on privacy in general about this time for various reasons. So in this world where the database are actually only syncing peer-to-peer and so on and so forth, how would you handle private data?
Yep. So I want to start this by saying that our entire approach to privacy, especially when you're talking about databases, but just in general, our approach to privacy is fundamentally flawed. Because we are always leveraging these centralized structures and centralized ideas of what a work group is and who should have access to data, we continue to leverage access to the data as the way in which we enforce some kind of privacy constraint. And I think that we already have enough evidence outside of like any kind of peer-to-peer vision to know that model is fundamentally broken. Data has leaked about every person on the planet almost at this point, right? Like, all of the data that was supposed to be private at credit bureaus, literally the State Department of the United States of America, like, these are places that have had huge data breaches, okay? So the idea that the solution to privacy is to constrict access to the data is not going to work. Like, that is not private data, that's just data that hasn't leaked yet, in my view. So even outside of decentralization, even if you just want to build like a better privacy story for a centralized structure, that data needs to be encrypted, and it needs to be encrypted in a way that the provider isn't able to see it. So it's not really private if the provider reads it in plain text and they decide who gets access to it. That's just not a workable solution in my view. So to me, the solution to privacy is cryptography. Like, you have to encrypt this data. And then you have to figure out what your kind of key management solution is for figuring out who gets access to this data and how they get access to it and how they mint new keys in the future and all of that. And that's a really kind of complex problem that goes beyond the database and beyond just the data structures that I work with. You're talking about kind of user workflows around key management that are quite difficult. And just in the last 3 months, there's been huge strides in this space, right? I don't know if you saw Microsoft Ion launched, but it's really like a fully decentralized kind of authentication and key management solution that's quite nice, that I think is actually going to be integrated as like a kind of login solution for a lot of Microsoft properties. And so there's really good stuff going on in that space, and I think that we'll get there soon. But it'll just be the case, not too long from now, where you can pretty reliably say that a user person is going to be able to hand me an identifier, and I'm going to be able to associate that identifier with a set of public keys, and I can use those for encryption. And I can they can give me access to a private key, or I can hand them a private key to add to something that I can use for encrypting that data. So if you kind of assume that is going to be solved and that people are working on that, then at the data structure layer and at the database layer, what we have to think about is, okay, what are the primitives that we offer to people for encrypting this data and moving it around? And then on top of that, what are the primitives that we have for network discovery, where people can isolate their network and then kind of control access to the data a little bit. So you don't start with like, a lot of people are still sort of concerned about taking encrypted data and putting it on a public network, because over some life cycle of that cryptographic algorithm, it will be broken. And so if people are archiving and saving that data long enough, that will eventually be broken, right? Like this happens all the time in like, international relations, where like we've been holding on to encrypted communications for decades, and eventually those algorithms are broken, and then we read a bunch of things that other countries were saying in private like decades and decades ago. So we probably don't want that model for all of our data on the internet. What we want to do is like we encrypt that data, and then we create kind of a more private discovery network for getting access to that data. And yeah, so that's kind of the approach that I would take to privacy in these databases.
Yeah, the discussion there, but about the centralized, decentralized model, at least with privacy, is become particularly relevant today with the exposure notifications with COVID-19 and that kind of thing, where these applications have gone to a decentralized model rather than taking all of the contact information, uploading it to a server and doing the checks there. Right, the keys are brought down to the device, and the checks are done locally to that individual user. So I mean, it's really interesting to see how some of these ideas are finally starting to kind of take root in real applications and in real world problems. And I think that there's a long way to go still on doing the right thing, and we absolutely, I 100% agree with you. We have to be leveraging encryption more and better, but it's a hard problem. I mean, key management alone is a terribly difficult problem.
Yeah, to be honest, it's key management is probably the thing that scares most developers when dealing with that model that you have described. So I don't know if I'm suggesting you what to put next on your multi-year plan for world domination, but that is one.
So this problem has a lot of people working on it. Like I mean, unlike some of the I am one of the few people that is really seriously trying to write decentralized databases right now. Like I'm not the only person by any means, but there's way fewer people working on writing decentralized databases right now than there are on like key management and identity. Like there's actually quite a few people. There's a big overlap of concerns here that go beyond just the stuff that we're talking about. You have issues of self-sovereign identity in struggling countries. You have you literally have aid organizations that go into third world countries and create a profile for a person and then have to burn that profile every year and start over from scratch because they can't put it somewhere where that government might be able to get at it. They literally you cannot tell certain governments, hey, here's all of the people of this particular ethnicity. Like that will go very, very badly. And so they really want to have a way where they can have a identifier to say, oh, here's this person. They are handing me their public key. I can now look at information about them because they shared it to me, but nobody else can look at that information. And I couldn't look at it if they hadn't shown me this, right? So there's tons and tons of overlapping concerns around just identity and identity management and key management, and a lot of people working on it. I think that we're just the usability part of this, the actual user facing bit, is the hardest part. And integrating that work into the technical side, I think, has been a real challenge for people. Contact tracing, I think, is like a best case use case right now, because it's not information that, like, as an individual user, I really care about keeping around. I don't need access to it. If I lose the key to it, like, who cares, kind of. It's mainly like I don't want this to be. I need this to be anonymized, and I need the people looking at it to be trustworthy, and I need it to not leak to just random people. So I think that's a really good place to kind of put our efforts right now, because one, it's contact tracing is probably like the number one problem that we should be solving with technology at the moment, given the state of the world. America is kind of proving what happens if you just decide to do nothing. If you do nothing, it turns out that
things go bad.
It's not great. Yeah. Things are much worse when you do nothing. But yeah, I like this is a good place where I think that we have most of the technology and the primitives, and we can apply them, and we get to avoid a lot of the really nasty user
Now,
interfaces.
one of the concerns is, that I've heard folks raise, is we move to a decentralized model. We have, these decentralized databases, peer-to-peer stuff, but what are the peers? Or, like you talk about serverless, there's still servers, right? If we were talking about a decentralized model and peer-to-peer, if those peers are still a server in the cloud somewhere, right, versus or is it on individual devices, like handheld devices that people are carrying with them? What are the peers in this world, and and can we ensure, since there are so many different levels of capability with devices out there, that they can be evenly distributed? For instance, not everyone can use the new exposure notification service from Google, Apple, because it doesn't work on iPhone 6, right? What is what's the vision there? And what's kind of the strategy for approaching those kind of things?
So this is somewhere where I think that we tend to get it wrong, and we kind of miss the forest for the trees a little bit. So I should preface this by saying, like, this is like my culture, and my people are like these peer-to-peer nerds, like like the people who hang out at Data Terra Nemo. Like Matteo is one of these people, like, you know what I'm talking about. And like we love this stuff, and we really nerd out about it, but I think that we have collectively really missed the bigger picture in our obsession with peer-to-peer, like with the actual peering of it, right? And by this, I mean that the most important thing here is not that every single person doing something is in a peer-to-peer network with a trustless relationship. The important thing is that the primitives and the tools that we are building applications on top of do not require a centralized repository, do not require a centralized database, do not require a centralized authority. If we just move to a model where I have a tool to build an application, and I can decentralize it, all of a sudden everything else gets much easier, where all of a sudden I can do serverless, and I don't need to worry about overloading a centralized database. All of a sudden I can build an application, and I can kind of not care about where the data is stored, right? Like the thing that is pushing me in this direction, and like I will nerd out about peer-to-peer protocols, and I will like go down that rabbit hole and have a lot of fun. But I don't think that the peer-to-peer networking problem is the most important problem to solve. I think the most important problem to solve is what I call the beg a billionaire problem, which is that we have these applications like Twitter, Facebook, whatever, and then we have some problem with them. Like we don't like some consequence of it, and we want that to change. And the only mechanism that we have for changing that is to beg a billionaire who runs that company to change it. That is literally the only thing that we're able to do. And the whole vision of the web was that we would actually be much more enabled to solve these problems, right? Like if you look at the browser as a platform, it is full of these hooks that you can use as a user to completely change your experience. Like you can just remove ads, right? Like the foundational monetary model of the entire internet, you can just remove, right, from your browser. Like that's crazy. There are things like Grease Monkey and all of these like, old school plugins where you could really start fiddling around with your experience. The thing that you can't fiddle with, though, is the most important aspect of value generation that these applications do. So for more than 10 years now, like almost 20 now, most applications, the value that they generate, most cloud applications, I should say, the value that they generate is not in individual user contributions. The value is in the connections between those user contributions. So the relationships between different people's data is the real value. And that's how value was created on the web, by the way. Like the web itself is a bunch of interlinking websites, right? So it's the value of the network collectively, not the value of any one application or one website. And what a social app does, what any multi-user application does, is that it takes these inputs from multiple people and it creates relationships. And then those relationships are where the primary value is. We do not have a tool right now Like I know a lot of like super woke developers that are really into these issues. They cannot build a reasonable application that, if it were to become popular, would not have a large database bill that they would then have to turn into a business, which would then have to turn into a situation in which we would have to beg a billionaire to solve this problem. Like, I'm identifying this problem right now, and I don't have a tool as a web developer yet to go and build a new application that does not eventually have the same problem if it were successful. And the issue that I have with really all of the kind of federated web stuff too, is that it works at this individual user level. Like if you want to go and run your own site and manage this kind of federation on your own, then you have like an exit door. But what you don't have is a way for a developer to build an application and get other users on it where they just get to bring their own services to bear. Like a really good example here that I'm really trying hard to get to right now is just a model in which, like, forget peer-to-peer for a second. I log into many, many applications with my Google account, right? Or my Twitter account or my GitHub account. And that all that does is it just verifies that I am who I say I am. It just says like I'm that email. It doesn't say, oh, okay, you're logging in with Google. Let me store all your data in Google. You're logging in with GitHub. Let me store all your data in GitHub now. That's not part of the model that we have for having users log in. So open source development is like 90% of all software development now, right? Like most of what is happening is actually like all the hard bits are happening in these open source communities. And the layer on top is like this user facing layer and a lot of these like centralization layers that we've been talking about. But 90% of the code that is in an application is open source. And open source developers currently can't really build multi-user applications without like creating like a foundation or a company or something else out of them, because they just can't handle the database bill. But if you just allowed people to log in with a service provider that said, hey, store my data here, and you could build a multi-user application that actually was able to create interlinks and relationships between data that existed in multiple places where that wasn't a constraint, then you would be able to have open source communities building all of these applications that are currently like completely off limits for open source developers, because you just can't handle the monetary cost. It's too much. I know a few people that have done this, that have actually like gone and built the foundation and all the structures around it. And it's unbelievably difficult. And having run a foundation, like I can tell you, it's not a fun thing to be operating. Like you can run a very successful open source project that is not user facing, that doesn't have this problem, and have huge impact and lots of contributors and a really vibrant ecosystem without ever dealing with, like, let me figure out what the foundational structure is and getting millions of dollars coming in from donations. Like most people don't want to deal with that. And that's kind of the model that we're going to. And so my answer to your initial question, which I took a long time to answer, I guess, where are the peers? The goal of my work is not to figure out where the peers are. It's to make that irrelevant. Like I'm fine with you pulling all of the blocks for your database out of a central repository. I don't care. But I don't want that to be the constraint, right? Like you should also be able to get those blocks out of an offline cache. And the thing that allows you to pull them out of an offline cache or out of a central repository or out of a peer-to-peer network is the same primitive. As soon as we make that work at the primitive layer, then you can do all of these extra things on top. Those become much, much easier. We're no longer constrained. And that, for me, is the most important problem to solve, at least in the short term. I love peer-to-peer networks, but we have a limit on how many things you can shove in a DHT. Like that is not like a solved problem. Like we're not going to be putting millions of keys in the DHT anytime soon. Like we have actual like research to go do to figure out how to make that work. Whereas something where you log in with GitHub and I store things, like I figured out literally last week how to store IPLD blocks in GitLFS. So you can just use a GitHub repo and GitLFS to store IPLD blocks. And you can, with GitHub Actions, with no additional permissions, just like have DAG-DBs get created and add data to them and check them back in and push to themselves via GitHub Actions.
As you're sitting here talking, I just keep going back to how similar at least the high-level concepts are to the original arguments for semantic web and linked data, W3C. Yeah. It all goes back to the same fundamental idea of a core set of primitives. In the semantic web case, the URL, right? It doesn't really matter where these things are actually stored, where they're at. We can still get at them in a consistent way. So it's interesting that we've come largely full circle back, and yet again, Tim is right. Was right. This is what things go.
This has been another episode of OpenHive.JS, the podcast for all things JavaScript from Nearform. Be sure to subscribe to OpenHive.JS on your favorite podcast player. Join us next time for more insights and opinions from the open source and JavaScript communities. Until then, I am Matteo Collina. Thanks for listening.